Okay, now I'm recording already. Okay, it's recording. Okay, recording. Good. So let us try this question. Uh, okay. So question 8. During an adiabatic process, an ideal gas. Sorry, someone want to join? Okay, good. An adiabatic process, an ideal gas does 25 joule of work. Calculate the change in internal energy of the gas during this process. Okay, so back to what we learned about adiabatic process. Okay, still remember adiabatic process? What do you remember about adiabatic? Adiabatic. What do you remember? Adiabatic. What is zero? Insulator, right? Must be insulator. So no heat loss, no heat flow. Q must be zero. Insulator. Yeah. Q zero. So go back to the formula of first law thermodynamic. Okay. First law of thermodynamic. First law of thermodynamic. It is this formula, delta U equal to Q minus W. Okay, so Q0, no heat, no heat flow. So Q must be 0. So that means the formula become delta U equal to negative W. Okay, now an ideal gas does 25 joule of work. So this gas does this amount of work. So how? Yeah, this work done is positive or negative? Who do the work? Who do the work? The gas does. The gas does. So this is a, well, you can say this is a work done by gas. Work done by gas. That means work done by gas means is gas expansion, right? Correct, not class? The gas push up the piston. The gas does the work. So expansion, volume increase. So if this one work done is positive or negative? Yeah, work done is positive or negative? Let me see. Yeah, forget already. Mustn't forget. Yeah, work done by system, work done by gas expansion. So work done positive. Okay. So this is work done positive. Work done is positive 25 joule. Okay, that means gas do the work, so got work done, positive work done. Okay, put it inside. So delta U equal to negative 25 joule. Yeah, substitute into here. So change in internal energy means we want to find change in internal energy means delta U lah. Correct or not, class? Delta U. So what happened? What happened, class? The delta U is negative. What does it mean, class? Delta U negative means what? That means the internal energy decrease, temperature decrease, become colder. The gas become colder. Why internal energy decrease? Because he used up some work to do. He used up some energy to do some work by expansion. Understand now? It uses its own internal energy to do some work by expansion. So that's why internal energy decrease. The gas become colder, means it lost internal energy. Negative. Okay. All right. B. A car tire is filled with 0.120 mole of ideal gas. The pressure of tire rises from 200 to 400 kilopascal at constant temperature. This is very important. This word, constant temperature. So this one tells you the process. Is it what process is this? Constant temperature. Isothermal. Correct or not? Temperature is constant. Temperature is constant. So that means this is a isothermal process. Isothermal process. Degrees Celsius, you need to change to Kelvin. Need to change to Kelvin. Calculate work done per mole by the air. Work done by gas. Okay. Well, so let's look at question B. Yeah. So this is a isothermal process because constant temperature. If isothermal, what do you remember, class? Constant temperature. That means temperature is constant. So internal energy also constant. Correct or not? If internal energy constant, that means no change in internal energy. Zero. Delta U zero. Okay? If delta U is zero. So if we want to refer back to the first law of thermodynamics, it is what? Yeah. Delta U equal to Q minus W. So Q is zero. Not Q zero. For isothermal process is delta U zero. Delta U zero. So Q equal to W. Right or not? For isothermal. Okay. He asked for work done per mole. Work done per mole, that means I need to find work done per divide by mole. Work done divide by mole. Isothermal process. Still remember the formula for isothermal process? Mean the work done. The work done formula, remember? The curve one. This one, nRT ln V2 over V1. The N, the number of mole, go to the other side. Then you can find the work done per mole already. Okay? Divide by N. This formula lah. Okay? Let's write down the formula. Work done equal to nRT ln V2 over V1. V final over V initial. Yeah? Do we have all the information needed? We have this is the number of mole. Okay, we have the number of mole. Yeah, and this is initial pressure. This is the final pressure. This is the temperature all the while. Okay, do you think can do it? Oh, he give you pressure. That means you must change your formula. You can also write as nRT ln what? P1 over P2. Correct not, class? I taught you just now. Okay, you can change V2 over V1 become P1 over P2. So temperature. Work done per mole. That means work done per mole. Go to the other side. So RT ln P1 over P2. Okay, temperature. I have the temperature, but I must change to Kelvin. Everything must. This chapter all Kelvin. Yeah, this chapter all must be Kelvin. If you are talking about temperature, must be in Kelvin. If change of temperature, then you can either degrees Celsius or Kelvin. If just temperature alone is Kelvin. Change of temperature, like we learned before, like expansion, thermal expansion, got change of temperature. That one is degrees Celsius, can either degrees Celsius or Kelvin. But this one, this is just temperature, not change of temperature. not change of temperature. So this is temperature, must be Kelvin. Be careful. And R is Rybert constant, yeah, molar gas constant. So 8.31, yeah, if you remember, yeah, R, where's the R? Earlier part now, molar gas constant, 8.31, yeah, joule per Kelvin per mole, 8.31. So let's write it down. So 8.31, temperature 30, must change, plus 273 lah. 30 degrees Celsius plus 273 must change to Kelvin. Lon pressure 1 to pressure 2, so 200 to 400. So that means pressure 1 over pressure 2, kilopascal over 400 kilopascal. Never mind. So the unit cancel off already. Okay. If volume, then V2 over V1. If pressure is P1 over P2. Be careful. Terbalik. Okay, so you should get the answer. Yeah, work done per mole. What's the answer? You press the calculator. The answer is, I just check the final answer. Yeah, this is 8B1. 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 So 8B1. Now negative 1.73 1.75 exponent 3 joule per mole. Yeah, negative. So negative 1.75 exponent what? Exponent 3 joule per mole. You know why joule per mole, class? Because work done over mole. Yeah, work done over mole, so joule per mole lah. Joule per mole. Okay, pretty easy. So heat transfer in the process, question 2. What's the heat transfer in this process? So question 2, heat transfer. So to find heat transfer, we refer to this formula, Q equal you know, this one, right? Refer to this formula. Because delta U is 0, because internal energy constant, delta U 0. So Q equal to work done. Okay, but this is work done per mole. So to find work done, I need to multiply the mole lah. Okay, so work done is equal to 1.75 exponent 3 multiplied by the mole, isn't it? I go above. So our mole is 0.12 mole. 0.12. So this is 0.12 mole. Multiply, finally you get the heat. What? Also negative. What answer? Just check the answer lah. I got what? Negative 209 joule. Negative 209 joule. Okay, negative 209 joule. That means this. What is mean by negative Q? What is mean by negative Q? Heat loss. Heat loss to surrounding. Okay, this is actually compression. You know that? Work done negative means compression. Compression means you supply energy into the gas, but the energy cannot enter. Yeah, we must not let the energy enter and increase the internal energy. So we must ensure all the energy enter is lost as heat. So I have to do it slowly. Yeah. All the energy enter, come out again into the surrounding. Yeah. Lost as heat. Okay. So that's all for question 8. Understand, class? Okay. Alright. So proceed. Question 2. Question 9. Okay. So okay. Okay, question 9. Okay, am I recording? Yes, I'm recording, yeah? Alright. Must make sure I'm recording, you know? Okay, good. Alright. Now, question 9. What process is this, class? What is constant? Pressure constant. What process? Isobaric process. Constant pressure, isobaric. You must know. How to find the area under the graph? Very easy, right? Just a rectangle shape, rectangle area. Write down first. This is isobaric. Excuse me. So pressure is constant. Pressure constant. Okay, volume changes, temperature changes. Be careful with the unit there. See that? Kilopascal. Here got exponent some more. All this must pay attention. All this. All the unit. Okay. So when gas changes from state X to state Y, the amount of heat transferred into the gas. This is important. Heat transfer into, or is it heat loss or heat absorb? Heat absorb. Yeah? Heat absorb. Because heat transfer into the gas. Heat absorb. So then we must know if heat absorb is positive lah. You must know. If heat transfer out of the gas, then Q is negative. Q is negative. This one heat transfer into the gas means heat absorb. Heat absorb, Q is positive. 1.0 kilojoule. Kilojoule change to SI unit, class. Exponent 3. Okay. Determine the change in internal energy. So the question asks for what? Change in internal energy. That means this is a delta U. Now he asks for change delta U, internal energy. Okay. So how to do this? Using your first law of thermodynamics. Okay. First law of thermodynamics. First law. Our first law of thermodynamics is delta U equal to Q minus W. So ada delta U kan? Ada delta U. Ada Q juga kan? Ada Q. Ada work done juga kan? Got area under the graph. So semua ada lah. So what you have to do is Q sudah ada. What is all this? Q sudah ada, tinggal nak cari work done saja, ya. Find the work done. So work done. How to find the work done, class? Work done is, be careful with this one, like this, go to the right, go to the right. So this is the initial, this is the final, so this is expansion. This is expansion. Expansion work done positive. Expansion work done positive. So so work done is pressure multiply. Pressure multiply the This is the pressure and this is the delta V, right? Delta volume. So just take V final minus V initial. Always we want to find, this is a pressure times delta V. Pressure times delta V. Pressure times delta V. So itulah V final minus V initial. Okay, let's do it. Yeah, let's do it. Pressure is what? 20 kilopascal. So exponent 3. Kilo is exponent 3 Pascal. V final 75. How? Final minus initial. Final minus 50. Be careful, here got exponent. So just right beside there, exponent negative 3. Okay? Meter cube. Everything in SI unit. Okay? So you got the answer, class? Sorry lah, my sound getting weird. Yeah. And then heat. So you use a calculator and press lah. Then the heat also you substitute there lah. Heat also you substitute there. Yeah, 1.0 positive lah, because heat absorb. Okay, and then minus all the answer. Okay, what you get from your work done. So delta U, what do you get for delta U, class? Delta U. So the answer is question 9. Delta U is positive 500 joule. Positive 500 joule. So what does it mean, class? What does it mean by positive delta U? Kalau delta U positif maksudnya apa? Kalau delta U positif maksudnya apa? Internal energy increase, temperature increase. Betul tak temperature ada increase, class? Betul. Cuma you check dia punya isotherm line. Di sini isotherm line. Di sini lagi satu isotherm line. So Y, the point Y is further away compared to X, right or not? So temperature increase. Maybe X is 300 Kelvin. Now expansion, constant pressure, become 400 Kelvin. Y is going to the right is temperature increase. Temperature increase, internal energy increase. We get delta U also positive. Understand, class? 300 Kelvin, 400 Kelvin is I just simply put lah, not really the real temperature. I just simply put. Okay. Okay, class. Next, question 9 done. Always use the first law thermodynamic. Okay. Ini dia. Ya. Tengok macam mana buat. Figure 3 shows pressure versus volume of ideal gas undergoing cyclic thermodynamic process. Yeah, A, B, C, D, A. Be careful, A first, then B, then C, then D, then A. So it start from where? It start from A. Then it go to B, go to C, go to D, go back to A. Okay. Now calculate the total work done of gas in terms of pressure and volume. Calculate the total work done. Total work done. That means area under the graph lah. What I can say is the work done actually normally is the one enclosed lah. Yeah, yang ini tak termasuk lah. Tak termasuk. Okay. But okay, look at here. Total work done in terms of P and V. That means answer in the terms P and V. No value. Yeah, just represent the answer in terms of P and V. Okay, class. So first talk about A to B. Is there any work done? Is there any work done A to B? Work done AB. Is there any work done? No work done because no area. Yeah, no area. How about BC, class? BC is expansion. That means is work done BC is the semua inilah. Huh? Okay. So work done BC. Work done BC is what? Work done BC is what? Expansion lah. This is isobaric kan? Betul tak? Tadi AB ialah isochoric, isovolumetric, isochoric. Ini isobaric. Isobaric nak cari dia punya work done ialah rectangle saja. That means pressure multiply change of volume. So how? What's the formula, class? Remember? Pressure multiply change of volume, which is pressure kamu ialah 2P lah. Ini pressure. Let write as 2P lah. I scared you confused. Yeah, you understand? 2P. This is V final minus V initial. So V final is C 3V. 3V. V initial is point B. Point B is V. V. Okay. So what do you get? 3V minus V, you get 2V. So you get 4PV. 2V, 4PV. We got it. 4PV. Okay. It's somehow it's positive work done because expansion, right? Expansion, work done by gas. Work done by gas. Positive work done. Expansion, get a positive work done. Work done. Work by gas. The gas push up the piston. A lot of explanation. Work by gas expansion. Okay, class. Next, CD. We also know lah. CD. CD is zero work done lah. No area. DA. This time go to the left. Isobaric also. DA also isobaric, but this one is compression. Compression, if work done positive, expansion, work done positive. Yeah, if expansion, work done positive. If compression, work done negative. Okay. Work done on the gas. Work done on the gas is negative. Yeah, gas doesn't do any work. Gas doesn't do any work, so get negative work done. Okay. So, samalah. Dia guna P darab dengan V final ini berapa? V final ialah VDA. D ialah initial. Kan? Final minus initial. So, dia jadi V tolak 3V. Bukannya 3V tolak V. Dia final. Kena ambil final tolak initial. Take the V final minus V initial. So, is V minus 3V. So, percaya tak? Negative work done kan? So, what is this? Negative 2PV. Okay? Negative work done because of compression. Work done on gas. Work on system or work on gas. Gonna compress. Work on gas. Negative. Okay, understand? So what is the total work done? Nak cari total macam mana? Total means apa kita buat? Work done A, B, C, D, A. That means is work done A, B campur dengan work done satu-satulah. B, C campur dengan work done siapa lagi? C, D campur dengan work done siapa lagi? D, A. So we get 0, positive 4 PV, 0, negative 2 PV. So in the end, positive 2 PV. Joule. That's the pendek kata dia adalah area mana? Dia ada area ini. Adalah area yang ini. Ya? Yang enclosed area. That is 2 PV. Work done by gas expansion. Yeah. Okay, class, understand? Question 10 already, see? Two more. Ya. Soalan belakang ni ya. Mungkin panjang sikit. Okay, never mind. Okay, so figure 4 shows a graph of pressure versus volume of an ideal gas, ideal monoatomic gas expands isothermally from state A to B. The gas then cooled at constant volume to state C. Gas is then compressed isobarically to D isobaric, got isochoric, got isothermal. A to B is isothermal. Highlight. Got expand isothermal, got cool at constant volume, got isobaric process, and then heated, return to isochoric again. See that? What's the total work done? Total work done, same thing lah. That means work done. You start from where? You must know you start from where. Important. Start from A. Start from A, initial point. Start from A. So all the unit you see, ATM, CM cube. You need to change. You need to know how to change all the unit. Yeah, you must change like volume to meter cube. Like ATM become Pascal. Degree Celsius become Kelvin. You must know how to change. Find the work done, total work done. That means total work done. That means total work done. That means work done by going A to B, to C, to D, back to A. Do one by one lah. Okay. Do one by one. Let's do it one by one. Work done AB. Let's do it one by one. Work done AB. A to B is isothermal process. Isothermal process. So what's the formula? Isothermal. Remember isothermal? Isothermal process. Nah, ini nRT ln V2 over V1 for the curve. Ataupun V2 over V1 ataupun pressure 1 over pressure 2. Ini dia. Okay. So let's do it. Work done AB is isothermal process. nRT ln V2 over V1. Ya, ataupun ini ialah V2 over V1 ataupun VB over VA. Understand, class? Because it's V final over V initial. V final over V initial. V2 or V1. Okay. Temperature I have. Temperature at A. Yeah, I got temperature at A. See that? That means this is a AB is an isotherm line. Isothermal line. You know? Isothermal line. Even the B, point B has the same temperature. Point B has the same temperature as point A. They have the same what I can say, class, they are the same isotherm line. 327. Oh, this one is degree Celsius. What I can say is, class, temperature at B is the same as temperature at A. Also, internal energy of B is the same as internal energy of A. Do you know that, class? Do you know that? They have the same internal energy, point B and point A, because they have the same temperature. If they have the same temperature, means both of them have the same internal energy. This is concept. Yeah. Okay. I got the temperature. Number of mole. Do I have the number of mole? I don't have number of mole, right? But what I can do is tak payah guna NRT kan? Sebab tak ada the number of mole kah? Tak ada kan? So how do you do, class? I teach you the trick just now. Kalau NRT tak ada number of mole, macam mana you buat? Macam mana you buat, class? I taught you already just now. Huh? What do you do, class? Nah, NRT boleh tukar ke P1V1 ataupun P2V2 kan? P1V1 equal to P2V2, Boyle's law. You know, isothermal process is Boyle's law. P1V1 equal to P2V2 also equal to NRT. Kalau soalan tak bagi number of mole, kita guna kaedah lain. Ya, kita guna kaedah lain. Ya, tak ada number of mole, kita guna kaedah lain lah. Okay, so guna PV pula. Understand? Okay. So, sama ada you nak guna apa? You want to use PAVA ataupun you nak guna PBVB. Do we have PB? No, we don't have PB, right? Pressure. So we only have PA. So we can only change to PAVA. We don't have PB. Yeah, we only have VB, but we don't have PB. Faham tak, kelas? Tukar ke PAVA sajalah. PB, kalau dia bagi PB, tapi dia tak bagi you PB. So, guna saja PAVA lah. Ya. Dia sama dengan NRT. PAVA equal to NRT. Ln guna VB over VA. V final over V initial. Okay. PAVA. So, okay, class. Let's calculate PA. That atmospheric pressure. You must change to Pascal, class. Why this question, Okay, never mind. Okay. Nah, pressure. One atmospheric pressure is 1.015 exponent 5 Pascal. This one is provided in the list of constant. List of constant in the exam, kan? Kalau di exam you tak tahu atmospheric pressure berapa Pascal, kamu tengok itu list of constant. Dia ada bagi nilai ni. Okay? Make sure you check your list of constant provided in the exam. Nah, what atmospheric pressure inilah. Kalau Kelvin nak 273 atau 273.15 pun boleh. Kami terima dua-dua. 273 ataupun 273.15. Okay. Okay, so how 1.013 exponent 5. Leceh sikit lah ya soalan ni. So PA 10 atmospheric pressure. Tukar ke Pascal SI unit. Mesti tukar ya. 1.013. 1.013 exponent 5 Pascal. Okay, that is pressure. Okay, and then volume. Hey, I need to change to cm cube. I need to change to meter cube. So volume A is 200. So 200 centicube. Centicube become, we know that centi is -2 kan. Tapi kalau centicube kuasa darab 3, -6. Don't make such mistake anymore ya. Jangan tulis -2 saja. Okay or not, class? Don't make silly mistake. Centicube. Centicube is -6 darab 3. And then ln, apakah volume dia? Volume ini you biarlah dalam cm cube sebab dia potong unit dia. So you biar saja dalam cm cube. 4000 cm cube divide by what? Volume A 2000 cm cube. Sebab dia potong je unit itu kan. So tak kisahlah unit apa, boleh saja. Potong saja unit. Okay. So what's the work done? We get the positive work done lah because this is expansion. Yeah. Okay. So boleh kelas? Saya tak kira ni. Tapi you kira sendirilah. Work done BC. Work done BC is 0 work done lah. Same thing to work done DA is also 0 work done because no area, nothing. DA. Work done CD. How about work done CD, class? Work done CD, you should get negative work done. So it is work done CD is pressure constant, right? Pressure constant. Only the volume changes and temperature. Pressure constant. So is final is D. So must use final minus initial. Okay. It's final minus initial also need to change to meter cube. Don't use cm cube. Okay. So pressure. I need to change pressure. This pressure at C lah kan. Actually pressure at in fact pressure at C is same as pressure at D lah. They have the same pressure lah. Isobaric what? Yeah, isobaric. So D and C have the same pressure. I give you pressure of C, 2 atmospheric pressure. So 2 multiply. You need to change to Pascal. 1.013 exponent 5 Pascal. And then volume. Take final volume, which is VD. VD is see, VD is equal to VA. 200 cm cube. So must change to SI unit also. 2000 centi cube. That means -6. -6 meter cube minus the initial volume. Initial volume is VC. So is 4000 -6 meter cube. Because centi cube, so is -6. Okay, class. Then you get a work done. Okay, so you get your work done, yeah. Work done, work done A, B, C, D, E is work done AB plus work done BC plus work done CD plus work done DA. You add up all together, you get the final answer. Yeah. This one, just now work done CD. This one should be negative work done lah. Yeah, negative work done. Yeah lah. Smaller volume minus bigger volume. Negative work done. Because it's compression. Compression is negative work done. Okay. This one is AB is expansion. Expansion is positive work done. Okay, final answer, class. Final answer. What's the final answer? 11. 999 joule. That's the answer. 999 joule. That's the answer. We done it. Yeah? 999 joule. More. You still get a positive work done. That means it is area. This positive work done means because the expansion more than compression. You see that? Expansion more than compression. That's why expansion more than compression. So that's why you still have positive work done. So it means this area. Area enclosed. Because expansion more than compression. So you get a positive work done. Work done by gas. Yeah. Okay, everyone, class. Boleh? Important thing is you must change to Pascal, meter cube, Kelvin, semualah. Itu mesti tukar ke SI unit sajalah. Itu yang penting, ya. Okay, last question. Then we can finish once and for all. Okay. Yeah. 1 mole of ideal gas is compressed isothermally from 4V to V. So 1 mole compressed isothermal. This isothermal process, class. Tulis dulu, isothermal ini apa? Temperature constant. Temperature constant. 1 mole. That means N equal to 1. Yeah? Somebody admit. Okay. 1 mole. 1 mole compressed isothermally from 4V to V. So this is initial. This is final. Yeah? Initial volume, final volume. Work done on the gas. Why you say work done on the gas? Because compression. Work done on the gas. So this one should be a negative work done. Correct not, class? Compression. Compression is negative work done. Energy enter into the gas, actually. Yeah? Energy enter into the gas. Okay? Work done on the gas. So negative work done. You must know. Compression, negative work done. Calculate the heat transfer during the compression. Is the heat absorbed or released by the system? Heat must be released. Because when you compress slowly, you must ensure all the energy enter come out again in the form of heat. Must make sure all energy enter and come out straight away. Ya, faham kah? Macam ini container. It's a good conductor. Yeah. So the moment we compress, energy enter into the gas. Energy enter into the gas. But we don't want to change the internal energy. We don't want to change the temperature. So we must make sure that this energy come out again in the form of heat. Q must be heat loss, negative. Work done compression is negative also. Understand? So when energy enter, energy exit, so the temperature is constant, so can maintain the internal energy and temperature to be constant. So this process must do very slowly. You cannot do it very fast like adiabatic. You compress very slowly. Make sure the temperature doesn't increase. Make sure the temperature doesn't increase. Energy enter, energy exit right away in the form of heat. What's the formula again? First law of thermodynamics. First law of thermo. What's the formula again? Delta U equal to Q minus W. Isothermal process, temperature constant. That means Change of internal energy is 0. No change of internal energy, right? Because internal energy and temperature constant. So no change in internal energy. So let's rearrange the formula, class. Q equal to W. W, negative W go to the other side, become positive W. See that? If compression, kalau compression work done negative kan? So Q pun akan jadi negatif. See that? Heat must exceed heat loss. Heat and energy enter and heat loss. Compression and then energy loss as heat. This must be a good conductor. This must be a good conductor. Made of metal or what? Okay. Okay. Wait. Question A. Calculate the heat transfer during the compression. Is the heat absorbed or released by the gas, by the system, by the gas? Heat released lah. Correct or not? So Q equal to, sebab compression kan, compression work done on gas, so negative work done, negative 4.5 exponent 3 joule. Work done on gas. So when work done negative, Q also negative. Q negative means what? Heat loss, heat release. Heat must release so that the temperature of gas doesn't increase. Heat released by system or heat released by gas. The system here refer to gas. Yeah, the system here refer to gas. Heat released by system, heat released by gas. Okay. If Q positive, then heat absorbed. Okay, calculate the isothermal process temperature. Oh, calculate the temperature. Can you? Question A, question B. Temperature. 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 Work done. This one use formula of work done because you already got the work done, kan? You got the work done. So work done equal to nRT ln what? V final over V initial. So work done on gas is negative 4.5 exponent 3 joule. Yeah, negative mole, 1 mole. See, 1 mole. 1 mole. R is molar gas constant. Temperature, yes, in Kelvin. Yeah, get in Kelvin. Ln, what's our final volume? Final volume is V. Compressed. V initial is 4V. V final over V initial. So V over 4V. Okay. Okay or not, class? V final over V initial. So, cut. Then you solve it lah. You solve it. And the temperature you get is what? Temperature you get is, where is it? See the answer? Heat release, yeah? Oops. 390.6 Kelvin. 390.6 Kelvin. Temperature 390.6 Kelvin. That's it, class. That's the temperature. Okay. So it's not that difficult, right, class? What do you think? What do you think, class? Yeah? Okay? Is anyone with me? Still with me? Okay. Right. So, okay. So that's, I think that's all for today's, yeah? Today, So we have finished. Yeah. So now you can prepare for your UPS lah. Yeah. Or you want to do the physics attack, follow the other question, the following question, physics attack. Now you can start doing past year already. Yeah, you can start doing past year already. All right. So let me off record. Okay, 1, 2, 3.